All right, hello once again. This is Jeff Scott of Rankin Technical College. If the acoustics sound a little bit different, I am taping this from inside of the office area here at Rankin, and there may be people coming in and out, and there may be noise outside, but I wanted to finish this because I'm halfway through with the lecture on Chapter 12 for Murox ASP.NET 4.6 with C# 2015 6th edition. Again, we are in Chapter 12, which was our Introduction to Database Programming. Here are some of the common SQL Server data types. We're going to be using SQL Server as our relational database management system of choice. Here are the tables that make up the Halloween database that we use in the book. You'll notice there is a one-to-many relationship between products and line items, so every one product can have 0, 1, or more line items. There is a one-to-many relationship between invoices and line items, so every invoice can have 0 or more line items. That should have been 0 or more also. There is a one-to-many relationship. The many side is the one with that's an infinity symbol, looks like a number 8 turned sideways. But there is a one-to-many relationship between categories and products, so every one category may have 0, 1, or more products. There is a one-to-many relationship between customers and invoices, so every one customer may have 0, 1, or more invoices. And there is a one-to-many relationship between states and customers, so every state can have 0, 1, or more customers. So the primary keys for these tables for line items, it's a concatenated primary key made up of invoice number and product ID. For products, it's the product ID. For invoices, it's the invoice number. For categories, it's the category ID. For customers, it's the email. And for states, it's the state code. In addition, you see that the line items table has product ID included as a foreign key, so we can relate to products and line items tables. And the line items table also has invoice number as a key, so that we can relate together these two tables. And technically, line items is more a jump table because it has the primary keys of the products and invoices table together. So line items table basically allows us to directly connect together or indirectly connect the invoices and products table through the line items table. In addition, you'll notice that the products table has category ID, and that is a foreign key so that we're able to directly connect the categories and products tables. You'll notice that the customers table has cust email in the invoices table as a foreign key so that we're able to directly connect the customers and invoices table. And you'll notice that this customers table also has state, which is the state code. So that's in there as a foreign key so that we're able to directly relate the states and customers tables. So we have what? 1, 2, 3, 4, 5, 6 tables, 6 primary keys. One is a concatenated, the other are just singles. And in addition, we have 1, 2, 3, 4, 5 different, at least, foreign keys. All right, so that's all fine. What do we do when we want to do this, work with this stuff? So let's say that, for example, what we wanted here was we wanted to be able to get all of the information from the products table. Okay, I'm just doing that off the top of my head. Again, this should all be review for you. But if we wanted all of the information from the products table, we would do what? We would type in select star from products. And that would give us every single field in the products table. What if we don't want all that information? What if all we want from the products table is the name and the unit price and the on hand, for example? Well, then we can type in select name unit price, this is all case insensitive, on hand, from products. All right, so this gives us everything. This gives us only select fields. What if we wanted that same information from the products table, but only when we have a number on hand that's less than 100? So in other words, let me move this up a bit. Then we can say where on hand is less than 100. Maybe we know that's our order point, where once we get to that point, we have to order more of a product. So this showed us everything. This showed us just select fields, but all of them. This showed us just select fields, but only when that criteria was met. All right. What if we wanted not just the product name, unit price, and on hand, but we also wanted the short name of the product? So in other words, what we want here is the same stuff that you see here, but we also wanted the short name. Well, right now, this particular query will not work because we're getting these three fields from this table, but we're getting this field from another table. So we could say here, short name, categories, but that still wouldn't be right. We have to do what's called a join on these two tables. So we have to say something like where products dot category ID equal categories dot category ID. And this where, since we already have the word where, becomes an and. Now that would work. And there's other ways to write this query also. But I want to actually show you one more of them right here. All right. And see if I can make this wide enough so you can see them both. There we go. I'm going to say here P dot name, P dot unit price, P dot on hand, and C dot short name. Then I'm going to say here from products P, categories C, where P dot category ID equals C dot category ID, and on hand less than 100. Now, what I've done is what's referred to as fully qualify these names, and I've used an alias. I could have typed in here products instead of P, products instead of P, products instead of P, and categories instead of C. Then I wouldn't have had this, and I wouldn't have had this. But I've done what's called alias the table. So in other words, every time I say just P dot something, it's as though I typed in products, so it's less typing. Anytime I type in C dot something, it's though I typed in categories dot something. So this is known as aliasing the tables. And once you alias, whether I alias or I type in products dot here, here, and here, and categories here, this is called fully qualifying my names. All right. Here I need to either fully qualify with products dot categories dot, or as I've done here, alias them. I couldn't just say we're category ID equal category ID. This would have worked just fine without this, and without this, and without this, and without this. It would have worked because name exists in this table but not in this one. Unit price in this table but not this one. On hand in this table but not this one. Short name in this table but not in this one. So we could have done that in different ways. All right. Many people who work with databases fully qualify everything all the time, as I've done right here. Okay, so those are just a couple of simple examples of a select statement. So you select one or more columns from one or more tables, and where it's got these in brackets, what this means is, all right, what it means is that those are criteria, and since they're in brackets, they're not mandatory. Now, we didn't put an order by in here, but we could have. So we could have said order by on hand, and actually this could have said here also P dot on hand, and this would have said P dot on hand. All right. So order by P dot on hand, and if I wanted them in descending, if I wanted them in descending order, I could have put afterwards DESC. So if I had any with 99, that would have been the closest to 100, but less than 100. That would have shown first, etc. So this is your syntax. Select one or more columns from one or more tables where any criteria, and then an order by. The where and the order by are optional. So here's their example of a select: product ID, name, and unit price, where the category equals props. When you run a query, you get what's called a result set. There's the other way that you can actually do a join. So I should just grab this. I don't like this syntax as much, but this syntax is now what's known as the recommended syntax. So I want to put it in here so you can see the other way of joining these. All right, so I could have said from products P inner join category C, where, I guess that where would have been an on. So we could have done it like that also. I think that is correct syntax. Now, it's not just that we have, in the way they showed it, it's not just that they have 5 lines and I have 4. To me, the way that I've written it, that where you see it up above in blue, is easier to understand, and that's just join, not join G, of course. But I think this is easier to understand and comprehend than this is. Okay, but the way that now is in blue, not the way I did it, but the way the book shows it, that is the recommended way of doing it, because that was set up specifically for relational database management systems, and it's supposed to actually work better than the way that I have shown you. Okay, but either one of them, just so you know, either one of them should work. All right. Let's continue on. So when you run a select like this, this is the results that you'll get. That's fine. How about an insert? Well, one thing I mentioned to you earlier, and I want you to see this because I'm trying to be complete here, is in databases, you oftentimes do what are called CRUD operations. CRUD is an acronym that stands for create, read, update, and delete. That's what CRUD stands for. All right. Now, instead of read here, read is the equivalent of a select statement. So anytime we use select here, we're doing the read part of CRUD. All right. Well, let's break this down, because the next thing that they talk about in here is how to do an insert. So let's grab their example here. And I'm going to jump back and forth as I'm doing this because I want you to understand what's going on here. Again, many books show keywords that you use in uppercase and non-keywords in lowercase. Okay? But this is a case insensitive language, so we could have put it all in uppercase, all in lowercase, we could have mixed the case, etc. All right? But what we're saying here is what we want to do look at it this way, that for lack of better words, I'm going to put these all in here so you can see what's going with what. Now hopefully I made this easier to understand and not harder. Let me cut down the size on this just a little bit. Cut it down to about 14. That was too much. 44. That'll work. All right. So let's look at what we've done right here. Okay. What I've said is I want to insert a new record into our categories table. The category ID will be food. The short name will be spooky food. The long name will be the very best in Halloween cuisine. So as we look at this, all right, as we look at this, hopefully this makes some sense to you. This is the syntax for doing it. It's insert into followed by the table name. Then we can list all of the field names. Then the word values, and you notice all the field names are in parentheses. Then the word values, then in parentheses, each field that we're putting into that particular field name. So that's the syntax. That's what they're showing you in the book right here. So insert into table name, your columns, values, and your list. Now hopefully that made sense. Okay. How about if you, okay, so that right there, I already said read equates to select. And insert that you see right here, that equates to create. Okay? Next, we have update. Well, what does that equate to? Update. Okay? And that's something like this. Update. Again, it's not mandatory that you use the uppercase. Update categories. And let's say set, which is a keyword. Short name equal, right now the short name is set to spooky food. Let's set it from spooky food, let's change it so that it's equal to now spookiest food. Now, I would not want to run a query like this because this says go through the entire table and reset every short name to spookiest food. I wouldn't want to do that. All right, I would want to say set it to spookiest food where the category ID is equal to food and the short name is equal to spooky food. So what I'm trying to tell you is when you do an update, if you don't put a where on there, it updates everything. And you typically won't. So if I leave this out, that's going to change the short name of every record in the categories table, every record, to spookiest food. But when I do this, it will only do it if the category ID is food and the current short name is spooky food. It'll change that one record probably to spookiest food. All right. And then we also have delete. And delete does just that. Now, if we type in this, if we just type in delete from categories, that gets rid of every single record in our categories table, which probably is not what we want. So again, just like with the update we used a where, with the delete we typically use a where. So where, now we can just add this stuff that we used before. Now we're saying we want to delete only where the category is food and the short name is spooky food. If we changed it from spooky to spookiest, of course, we'd have to do that. All right. So what they show on the book here is update will change an existing record and delete will remove an existing record. With an update, if you don't use aware, or with a delete if you don't do aware, it either updates all records or it removes all records. Typically, that's not what you want. All right? Let's say, going back to what we looked at before, remember this thing that we did up here? Let's say I'm constantly typing in this command that you see right here. So I'm constantly typing in this. And I'm typing it in every day. Well, unless I'm a really good typist, in the inner join, again, this can be in lowercase. As I mentioned, it doesn't matter. But I'm constantly typing this in. And it's like, boy, isn't there a faster way of doing it? I can take this and I can type in, for example, create view, and we'll call it on hand. As. Now, what we're doing is we've taken all that and we've saved it with a new name. So now if I just say select star from on hand, since I've created a view which is a saved query, when I go and when I type in this, it runs this. And as you can see, it's a lot less typing. Views are a neat thing because they allow different people to view a database in a different way. If you don't understand what I mean, and you probably do whether you realize it or not, it's like if I go into a bank and I want to deposit some money, I can go up to a bank teller and give him or her a check or cash or whatever, and they'll deposit into my account. But if I say I want to take out a loan, they're going to typically say, well, you have to talk to a personal banker, because the personal banker is the person you can talk to get information about a loan. So they can view your data differently than a bank teller can view your data. So what views allow are different people using the same database to have different views of the data. All right, they give their own example of that. Okay. All right. The next thing that's discussed in here are stored procedures. Well, again, I can create a procedure. Now you say, well, that's the same as a view. No, it's not. There's two big differences. First, this is actually executable code here. So I'm saying every time I call that procedure, I'm telling it to execute this. But the main difference is, if you look in here, you'll notice there's these @ signs here and here. What that means is as I'm running the program at runtime, I can tell what state I want to look at. So if I set the state equal to California, now I'm saying, give me the last name, first name, state, and email from all customers who are from California. If I run it again and I put MO in there, it'll do the same thing, but just with customers from Missouri, NY, New York, etc. All right, that gets us almost to the end of the chapter. But the picture that you see on the screen right now is what's shown in the book on page 433. So there's only about 6 pages left in the chapter. Now, on this page, on this picture that you see right here, what they are showing you, and I'm just going to keep going. This will be a little longer tape, but I only have 3 or 4 slides to go. So this one will be probably closer to a half an hour. Is you see a data set, data table, data adapter, command, connection, and database. Well, this is a picture of ActiveX data objects, or ADO.NET. It uses 2 types of objects to access data in a database. It uses data sets, which can contain 1 or more data tables, and it uses .NET provider objects. All right? And if that confuses you, look at it this way. This usually involves little to no coding. This will typically involve coding. So when you want to retrieve data from a database and store it in a data table, you use one of these data adapter objects. You issue a select statement, you store that in a command object, and you use a connection object to connect to the database and get the data you want. This won't make sense until we start working with it. To update the data in a database, it's done the same way, but instead of a select, we'll do an insert if we want to add data, an update if we want to modify data, or a delete if we want to remove data. That's what will be stored in that command object. All of the AWD.NET objects are implemented by classes in the system data namespace of the .NET framework. So that always has to be added. All right. When you use an SQL data source, the connection that you make to the database, it's automatically closed after each time you do a select or an insert or an update or a delete. Because of doing that, the application must work with a copy of the database and the database data, not the actual database itself. The architecture that's used to do this is referred to as a disconnected data architecture. It makes it for a more complicated structure, but it improves system performance because it uses fewer system resources. Also, it works well with ASP.NET web applications, which is what we're going to be doing because those types of applications are inherently disconnected. All right. Where this can really become important, and this is on 434 and 435 in the book, and that is when you have two different people working with the same database data at the same time. Even though they each have their own copy, what happens if they both change the same record? So what happens if it's a bank account and I am there's a person who comes in with a check and they say I want to deposit that in the account, and at the same time I'm doing that, maybe it's a husband and wife. The wife comes in and tries to withdraw money from the account. Well, if they were both working with the same copy of the same database, one change could overwrite the other change. So they both work with their disconnected copies. But what happens when you want to write them back? Well, this is what's called concurrency. It's when two or more users retrieve data in the same row of a database table at the same time. Because ADO.NET uses this disconnected architecture, the database management system, the DBMS, can't prevent this from happening. All right, so if two users try to update the same row at the same time, the second users, the one who writes last, could overwrite the first users. Whether or not that happens depends on the type of concurrency control you use. There's two types. There's optimistic concurrency, where the program checks to see if the database row that's about to be changed, either an updated or an insert or a delete, has been changed since it's been retrieved. If it has been, it doesn't allow it to go through. All right. If you don't have optimistic concurrency in effect, it does what you may not want to have happen, and that's last in wins. Whoever writes last, their change is saved, and the earlier change is not saved. For many applications, concurrency errors rarely occur. But if concurrency is likely to be a problem, all right, you'll want to be using optimistic concurrency. Another way to avoid concurrency errors is to write your program so that it retrieves and it updates not the entire table at one time, just a particular record at one time. Then the chances of two people where one overwrites the other become minimized. All right, and the last thing that's discussed in the chapter, this is the picture that's shown in your book on page 437. And it talks about how to work with data without using a data adapter that we talked about earlier. By default, when you use an SQL data source to work with data in a database, a data adapter is what's used to retrieve the data and store it in a data set, and that's what we talked about earlier. But you can work with data in a database without using an adapter. That's what they show here. You still use command and connection objects, but instead of using a data adapter to execute the command, you execute the commands directly in code. When you do that, you have to provide code to handle the result of the command. So if you issue an insert, an update, or a delete, for example, the result will be an integer that indicates how many rows were inserted or updated or deleted. You can use that information to determine whether or not the operation was successful or not. For example, if you try to do an insert of a single record, the number that gets returned is 1. If you try to modify something and it returns 0, that means nothing was modified. If you try to delete something and it returns 0, nothing was deleted. So if you execute a command that contains a select statement, remember, select can't change the data. Select is the read. The result is a result set that contains just the rows you requested. So then you can use what's called a data reader object. A data reader object is a read-only object. It reads only. All right. It's also known as a fire hose. So if you've got 10 records and you read in record 1, 2, 3, and 4, all you can do with a data reader object is read in the last 6 records. You can't go back to the beginning and reread them. We'll talk about this more in Chapter 17. So this chapter was an introduction to how relational databases are organized, how columns are defined, how tables are related. We talked about CRUD, where the C in CRUD is our insert, the R in CRUD is our select, the U and the D are update and delete, respectively. We talked about how to create views, and we looked very quickly at a stored procedure, and we ended the chapter by talking about the ADO.NET components, the data set, data table, data adapter, command, and connection. We talked about what disconnected architecture is and a little bit about concurrency. Now that's it for this chapter. As we go on, we're going to look at different ways of manipulating database data using the different parts of the .NET framework, working in conjunction with the SQL Server database. So in the next chapter, we're going to talk about how to use SQL data sources. So that will be the next chapter that we go over in here. So 13, 14, 15, 16, 17, and 18, along with 12 that we just completed, those will all be chapters that will discuss databases. And I'll be back with that one shortly.